Hello everyone. In this particular video, let us try to understand how to determine the step response of an LTI system given the impulse response. So, do we have any idea? So, what is this step response? Wait. Yeah. Okay. So, what is step response represented by S of n usually, right? S of n equal to wait, my handwriting. Okay. S of n equal to what's the formula? Minus infinity to n, right? Oh, minus infinity to n of h of n. Okay, so it is minus infinity to n of h of n. Okay, I am extremely sorry for this thing. My handwriting has gone bad with this. The comfort with my uh, you know the touchpad is not so good. Okay. So this is the formula. So what does this formula mean, by the way? So what this formula means is from all the values, if at all you want to value, say at n equal to 3, add all the values of the impulse up to 3. Suppose you want to value at n equal to 4, add all the values up to 4. Okay, so it's a cumulative sum of the impulse response is the step response. Okay, the cumulative sum of the impulse response is step response. Okay. So let us do this particular thing. So here is our uh, program. Okay, so two things we will do. Okay, so let us find the step response for two types of impulse responses. One is alpha to the power n. Okay, so here I have taken 2 to the power n. And we can change to 2 alpha or whatever. See, here I have taken 0.5, here I have taken 2. Okay, both are fine. Then we will take some other sequence. Impulse response equal to 0.5 to the power n, u of n minus 5. Okay, so let me tell you the difficult part. Okay, or the interesting part is to define the sequence. Okay, to generate the sequence h of n. Once you can generate, it's all about cumulative sum. Okay. So about the first particular sequence, let me just add a multiply this with u of n. Okay, so when I put this u of n along with this h of n, I am telling that this signal alpha to the power n, it exists only on the right side, because I'm talking about a causal signal. Okay. Whereas this particular signal, you can see it is starting from u of n minus 5, right? So it is starting from plus 5. Okay. So let me have why it should be causal. Let me have a n plus 5. Okay. It doesn't matter. Okay, n plus 5, and let us start. Okay. So let me define how many values do you want, by the way. H of n equal to alpha to the power n t of n is infinite sequence, but we are not interested in infinite number of values. We are interested in say first 50 values. Okay. First 50 values. Let me define a starting point here. Since it starts from 0, later I want to plot my answer also should start from 0, right? So let me define this. And while x-axis, let me define x-axis also. Okay, so starting point, as I say, 0, and let me get some 50 points from 0. Okay, so starting point plus 50. Okay, so how do I define my impulse response? So it is alpha to the power n into u of n. Okay, now here I will not write any u of n, but since while calculating the values, I only start from 0 and I will calculate up to 50 values. Okay, so what did I say? 0.5 to the power n. Now since my n is starting from 0 and going till 50, okay, so I am covered here. So it takes only the positive values. Okay, it only takes the positive values. Whereas, okay, shall I make this as a 2? Okay, so let me have it as a 0.5. I will change here only as 0.5. Okay, so I hope you know what I intend to say here. You can have a 0.5, you can have a 2, or whatever the value. Okay, 0.5 makes sense, by the way, because 0.5 to the power n into u of n is a stable system. 2 to the power n into u of n is unstable. Okay, so this number makes sense. Okay, got this particular thing. 0.5 to the power n t of n, when I wanted to define, I started from 0 and I went till some 50 points. I used a dot power, okay, a scalar power of individual values to the power 0.5 to the power 0, 0.5 to the power 1, 0.5 to the power 2, 3, 4, and up to 50 values. For the second sequence, 0.5 to the power n t of n plus 5. Here, what I intend is, okay, let me not put a star there. Okay, you will get confused with the convolution. Okay, let me multiply u of n plus 5. This means this particular sequence starts from minus 5. Okay, so for that, what arrangement should we make? Okay, now see here, for, okay, n plus 5. For this particular thing, my sequence should start from minus 5. So the starting point is minus 5, and I want to have up to 50. Okay, I want to have the values up to 50. So here I have defined as n from minus 5 up to 50. Here what I had done, L plus starting point. No, no, no. I think this is not good. Let me have it up to L1. Let me have the values up to 50. Okay. So why I'm showing this, because as I told you, this is the biggest part. The defining the sequence is the defining the impulse response is the biggest part. Okay. So it said u of n plus 5. My starting point, I only defined it as minus 5 to 50, then 0.5 to the power n. Had I had something like two sequences, something like this, plus 0.5 to the power n, then you would have simply written it here. Okay. That's it. Let's keep it simple. As I said, let's keep it simple. Okay. Now what? Surprisingly, we almost reached the end of the sequence. Okay. So first we have to display. Let us display an impulse response and step response. So what did I say? The step response in the beginning. Step response is the simple cumulative sum of the impulse response. That means if at all I want to know step response at 4, all the values up to 4, step response at 1, all the values up to 1. So I'll use the command cumulative sum, cumsum. Okay, cumulative sum of the impulse response. That should give me the answer. Shall I try? Let me see this. It's a very bad program actually, because the program is not interactive. I'm not expecting you guys to enter the impulse response and you guys try to type out things. So no. Okay, it's not that much friendly program. It's just okay. Yeah. Okay, okay. Now see, there I have a graph. Wait, let me show you by sharing the proper screen. Here it is. Okay. Yeah. Now, can you see the graph? So this here is my impulse response. 0.5 to the power 0, 1, then 0.5, 0.25, 0.14, and so on. And this you can see is the step response. So first value is 1, second value is 1 plus 0.5, right? The value at 1 is 1 plus 0.5. For the current value plus previous value. Here, 1.75, because it's 1 plus 0.5 plus 0.25. And here, what's the value? So here the value is 1 plus 1.875. Okay, got this particular thing. That's that. Okay. So similarly, what about the other one? Let us go back. Our second signal, it's waiting. Okay. So for the second signal, let me have some only 10 values. Okay, let me have some 10 values. Okay, because too many values spoil the party. Okay, for this I made the up to 10 values. I want to check. Okay, I'm starting from minus 5. I will go till 5. Okay, here also see u of n plus 5 also, that's why my starting point is minus 5. So you have to define the signal. Okay, somehow you have to define the signal. That's the amount of comfort I expect you guys to have with MATLAB. Okay, so let us run the second program. Second thing. Okay, there. Uh, I'm not displaying. Should I display the answer here, by the way? If at all you want to display the answer, so you should type display step response. The answer will display here on the screen. Too many values on the screen. No. But you need to write it in observation. Okay, that's why. Yeah, makes sense. Okay. I think it should not be there in the bracket. Or should this be? Yeah. You can see the values here. Okay. Simple accumulation of all the values. Okay. 32, 48. What just happened? Why this is showing 32 and 48 and 56? Why is it showing 32, 48 and 56? There is some catch. Okay. Something has gone wrong. Okay. 0.5 to the power n we have taken. Starting point is minus 5. Okay. Starting point is minus 5. 0.5 to the power minus 5 is a very big number. Okay. 0.5 to the power minus 5 is a very big number. Then afterward it goes on reducing. Okay. So it's always good to know what answer is you are anticipating. Okay. Okay. Similarly, let me display the answer here also. So improve the program. Okay. As I keep telling you, can always have a better program. Okay. My programs need not be correct and complete ones. You can always have better programs. Okay. Display. Okay. So okay. That was step response here. What are I trying to do? Did I display the impulse response? No, step response only. Let me run the program now. Let me run the second one now. Here, you cannot see anything on the screen, right? Yeah, the answer has been displayed. But let us go and see the graph that has popped up for the second case. See, very large numbers here. Okay, you can see the numbers. Okay. So understand the formula. Summation minus infinity to n of h of n. Okay. Understand. I do not want even a single student to by heart the formula. I want you to understand what it means. It simply means a cumulative sum of the impulse response. That is my step response. Okay. That was the problem. Okay. And we got the solution. That's, thank you.